The first thing most people know about the Hubble Space Telescope is the pictures, pillars of creation, glowing nebula, galaxies stacked like sand on a beach. But that's not actually what makes Hubble unusual. What makes it unusual is something almost nobody thinks about. It's the only major space telescope ever built that astronauts could physically open up, take apart, and rebuild in orbit. Every other space telescope we've ever launched, including the one that replaced it, is a sealed, one-shot machine. If something breaks, it stays broken. Hubble was different, and the story of why reveals something most people get backwards about how this telescope became famous in the first place. Here's the assumption most people carry around, that Hubble is beloved because of its optics, some flawless piece of glass that just happened to be really good at seeing deep space. The truth is almost the opposite. Hubble launched in April 1990 with a primary mirror that was ground wrong. Not wildly wrong, off by about 2.2 microns, roughly 1/50th the width of a human hair. But in optics, that's enormous. Light bouncing off the edges of the mirror focused at a slightly different point than light bouncing off the center, a defect called spherical aberration. Instead of crisp stars, Hubble produced fuzzy blobs with hazy halos around them. Newspapers ran headlines calling it a $1.5 billion mistake. It was, for a couple of years, one of NASA's most public embarrassments. So why didn't that failure just end the mission? Because of a decision made almost a decade earlier, for reasons that had nothing to do with anticipating a broken mirror. Hubble was designed during the Space Shuttle era, and NASA planned for it to operate for 15, maybe 20 years, an unusually long lifetime for any piece of hardware. To make that realistic, engineers didn't just build a telescope. They built a telescope you could work on. It has handrails on the outside for astronauts to grip. Its scientific instruments aren't soldered in. They're modular units, the size of phone booths that slide in and out like drawers, connected with standardized fasteners sized for gloved hands in a pressurized suit. The whole spacecraft was engineered around one core assumption. The space shuttle would periodically fly up, dock with it, and swap out aging or outdated parts, the same way you'd upgrade the parts in a desktop computer instead of throwing the whole tower away. That architecture wasn't built to fix a mistake. It was built to keep an expensive orbital asset useful for decades in an era when launching anything to space was rare and costly. But it meant that when the mirror flaw was discovered, NASA suddenly had an option no space telescope has ever had before or since: send people up to fix it. In December 1993, the Space Shuttle Endeavour carried a crew to Hubble on mission STS-61, one of the most technically demanding spacewalk campaigns ever attempted. Over 5 spacewalks, astronauts didn't repolish the mirror. You can't do that in orbit. Instead, they installed a device called COSTAR, which stands for Corrective Optics Space Telescope Axial Replacement. Think of it as a set of glasses, a package of small secondary mirrors positioned precisely to intercept the light after it bounced off the flawed primary mirror and bend it back into correct focus before it reached the cameras. It was, quite literally, prescription lenses for a telescope. When the corrected images came down, the difference was staggering. The same telescope that had produced smeared blobs was now returning some of the sharpest images of deep space ever captured. That moment is usually told as a redemption story, and it is one. But the more interesting part is what it proved: that a space telescope didn't have to be a single frozen attempt at perfection. It could be treated like an evolving instrument, something you could keep improving instead of just hoping you got right the first time. NASA then leaned into that idea. Over the next 19 years, 4 more servicing missions visited Hubble. Astronauts didn't just fix the mirror problem once and leave. They replaced gyroscopes that had worn out, swapped in fresh batteries, upgraded solar panels, and installed entirely new science instruments that didn't exist when Hubble first launched. The Wide Field Camera 3, the Advanced Camera for Surveys, the Cosmic Origins Spectrograph, these weren't repairs. They were straight-up technological leaps installed into a telescope already in orbit. By the final servicing mission in 2009, Hubble had effectively been rebuilt from the inside multiple times. Some of its components today have almost nothing in common with what launched in 1990, apart from the same outer structure and the same mirror, ground wrong, corrected, and then made irrelevant by newer cameras that compensated for it in software and optics anyway. This is the part that should feel strange when you compare it to what came after. In December 2021, we launched the James Webb Space Telescope, arguably the most important space observatory since Hubble itself. Webb has no handrails, no astronaut-friendly fasteners, no modular instrument bays meant to be swapped out. It was built as a single, sealed, extraordinarily precise machine meant to work exactly right on the first attempt, because nobody is ever going to physically visit it. The reason comes down to something simple. Location. Hubble orbits about 540 kilometers above Earth, well within reach of a space shuttle. Webb orbits around a point called the second Lagrange point, L2, roughly 1.5 million kilometers away, about 4 times farther than the Moon. That distance isn't arbitrary. L2 is where Webb can keep the Sun, Earth, and Moon all behind a single sun shield, keeping its infrared detectors extremely cold, which is essential for the kind of observations it's built to make. But it also means Webb sits somewhere no crewed spacecraft has ever traveled to, and none is currently capable of reaching. So even if Webb had been designed with swappable parts, there would be no way to service it with people, at least not with any technology that exists today. And the space shuttle, the vehicle that made Hubble's entire servicing program possible, stopped flying in 2011. Without it, even a telescope in Hubble's own orbit couldn't be repaired the same way anymore. NASA has floated ideas about robotic servicing missions for future telescopes, robotic arms, and refueling ports controlled from the ground. But nothing at Hubble's level of hands-on human repair has ever flown since, and nothing is currently planned to. Which means the choice to make Hubble serviceable wasn't really a permanent policy. It was a product of one specific decade, one specific vehicle, and one specific orbit, all of which have since disappeared. We built one telescope that could be opened, upgraded, and kept alive by human hands, proved spectacularly that the idea worked, and then moved on without repeating it. Not because it failed, but because the entire infrastructure that made it possible no longer exists, and the best future science increasingly requires orbits so far away that no astronaut can reach them anyway. There's a kind of quiet irony in that. The flawed mirror is the reason most people know Hubble's name, but the flaw itself wasn't ever the point. The real story is that for about 2 decades, we had a working model for space telescopes as long-term, upgradable infrastructure, the same way you'd think about a power plant or a bridge, something you maintain rather than something you launch and abandon to fate. Hubble's instruments today are unrecognizable compared to 1990 specifically because engineers assumed from day one that the mission wouldn't be static. That assumption is what let a broken telescope become the most productive scientific instrument in history, generating over 1.5 million observations and more than 20,000 peer-reviewed papers, spanning exoplanet atmospheres, the expansion rate of the universe, and supermassive black holes, all from a piece of hardware that was declared a disaster within its first year. Hubble is still up there right now, still taking data over 3 decades after that botched mirror nearly ended the program before it began. But its orbit is slowly decaying, and without another shuttle-era servicing mission, which will not happen, it will eventually fall back to Earth, likely sometime in the 2030s, its final chapter driven by simple orbital mechanics rather than any technical failure. When that happens, it won't just be the end of one telescope. It will be the end of a particular way of thinking about space telescopes altogether, as machines you build a relationship with over decades, rather than machines you launch once and trust completely. Every telescope since has gone the other way. Build it perfectly on the ground, test it obsessively, launch it somewhere unreachable, and accept that whatever state it arrives in is the state it will stay in for its entire working life. That's the actual legacy hidden behind Hubble's photographs. Not that it eventually took great pictures, but that it's the last of a kind of machine we decided, deliberately, not to build again,